guys, welcome back. So today we are going to be talking about, you guessed it, money. Okay, to be more specific, we're going to be talking about interest. There are different ways to calculate interest. In earlier course, not our course, we had talked about simple interest. We're not going to focus on that today, but it doesn't hurt to recall it. Okay, so simple interest is one way to calculate interest. To calculate the interest, you're going to take the principal, multiply it by the rate, multiply it by the time. And then to find out how much money you have at the end, you're going to take your principal or starting balance and then add to it the principal. So again, today we're going to focus on a different way to calculate interest. We're going to focus on compound interest. The question is, what is compound interest, or what is so special about it? In a nutshell, the cool, you can read it, but in a nutshell, the cool thing about compound interest is that you earn interest on top of interest. So it says method of calculating interest where interest earned over time is added to the principal. So again, in short, cool thing about compound interest is that you earn interest on top of the interest. Okay, we have two different formulas to calculate the compound interest. Depending on what information is given, that will determine which of the two formulas we use. Okay, the first one is given by, bear with me, it's A equals P open parenthesis or times 1 plus, it looks like a T, 1 plus R over N close parenthesis raised to the NT power. Okay, do we have to memorize that? No, you can just put it in your note card and you're good. So let's go ahead, bring in some meaning to all these variables. Okay, so A, what's so special about A? So A is your final amount, so how much money you have with the interest. P is your principal, R is your rate or interest rate, and new to our life is the number of compounds per year. Okay, in semi-English, it's how many times they pay out the interest each year, and we'll go over that in a bit. Okay, raised to the n, we had talked about what n is. N is the number of compounds per year, or in English, it's how many times they pay out the interest per year, and then t is the time. Okay, now the principal is pretty much something that's not going to change. Well, it's set. R, whatever rate they give you, time, whatever they give you, n. Okay, now let's bring in some meaning to n, or the number of compounds per year. So the question is, how can I tell if n is this or n is that? Unfortunately, in these problems, they're not going to tell you, hey, n is this or n is that. You have to do a little bit detective work. So if in a problem it says, hey guys, the interest is compounded annually. Okay, so n is the number of compounds per year. Okay, so how many times do they pay out the interest per year? If they do it annually, then they're only going to pay the interest once per year. So if they say interest is compounded annually, that is code for n equals 1. Okay, if they say good news, interest is compounded semi-annually, well, that is code for they're going to pay the interest twice per year. So we have n equals 2. What if they say interest is compounded quarterly? If interest is compounded quarterly, then that means that they're going to pay out the interest 4 times per year. So that's code for n equals 4. Okay. Now, what if they say, oh, great news, interest is compounded monthly. Compounded monthly? Well, there are 12 months in a year, so that's code for they pay out the interest 12 times per year. So n equals 12. What if they say, hey, I have good news, interest is compounded weekly? So I'm like, okay, how many times are they going to pay out the interest per year? Well, last time I checked, there's 52 weeks in a year, so I guess n equals 52. Now, what if they say, good news, interest is compounded daily? So the question is, oh man, how many days should we use? Should we use 365 or the leap year thing? If you want to be really specific, I guess it's 365 and a quarter, but we don't have time for that, okay? So we use n equals 365. Now, some of you may say, can we use n equals 360? No, because we'll be shy by 5 days, okay? So if the problem says interest is compounded daily, the question is, how many times per year are they gonna pay out the interest? It's gonna be 365 times a year. Okay. Now, what if they say, good news, interest is compounded continuously? I'm like, oh man, like what does that mean? How many times is the interest paid out? This doesn't make sense to me. So check it out. If they give you a finite number of compoundings, okay? If they give you a finite number of compoundings, then you're going to use this formula, okay? But if the problem tells you that the interest is compounded continuously, then you're going to have to use this exclusive formula, this other formula that's used exclusively when the interest is compounded continuously. And that reads A equals P times E raised to the RT, okay? The variables mean the same thing. You know, A is your ending balance or your final amount, you know, principal plus interest. P is your principal, E is just a constant. What was it, like 2 point something? R is your rate, and T is your time in years. Cool. So let's go ahead and do a fun problem and then take it away from there. Okay. So we have fun problem number 1. Yeah, you saw that. Okay. So it says, assume you invest $10,000 in a savings account that makes 2.5% interest compounded semi-annually. Assume you plan on keeping the money in the account for 30 years. What will be the account balance at the end of those 30 years? Okay, that's like too much information for me. So I'm going to tell you what I do. I just highlight things, whether I use an actual highlighter or I circle. I think the highlighter doesn't translate too well. Well, you can kind of see it, but I'm going to circle things, okay? So it says, assume you invest $10,000 in a savings account that's something. So the principal, what is that? Principal is the money that you invest, deposit, or borrow. Assume that you, I'm putting the word that because that's how I speak. Assume you invest $10,000 in a savings account that makes 2.5% interest. So we know that the rate is 2.5%. Fantastic. Compounded semi-annually. Okay, I see the word compounded, so I'm like, I'm gonna go ahead bust out the N. Okay, so if they say that the interest is compounded something, then we know we're gonna have to use the formula for compound interest, which is today's focus. The question is it gonna be N equals 1, N equals 2, N equals something? Okay. If the interest is compounded semi-annually, that means that they're going to pay out the interest twice per year. So that is code for N equals 2. So those are just things that you're going to have in the back of your mind. If the interest is compounded annually, semi-annually, so forth. Okay? Keep on going. Assume you plan on keeping the money in the account for 30 years. So we have more information. Time equals 30 years. Okay? And the question is, what will be the account balance at the end of those 30 years? Okay, so what is that final amount? I'm going to go ahead and put A equals because that's what A represents, the final amount with interest. Okay, so we had already talked about that we are going to be using the compound interest formula. Let me go ahead and write out the formula. So the compound interest formula reads A equals P times 1 plus R over N raised to the NT power. Okay, now someone asked, how did you know which of the two formulas that you use? If we have a fixed or finite number of compoundings, then we use that long one. But if it says that the interest is compounded continuously, then we use that shorter one, A equals PERT. Don't say that, okay? A equals P times E raised to the RT. Okay, so that's how you know which of the two we use. Okay, so we wrote down the correct formula to calculate the final amount. Now we're gonna, with your permission, I'm gonna write down what's given. I know that we highlighted, but I need to organize myself. So we have that the principal is 10 grand. Oh, sorry, $10,000. Okay. The rate is 2.5%. With your permission, we're gonna write it in decimal form right now, which is 0.025. And if we're having a moment going from percent to decimal, see me after class. What else do we know? We know that the interest is compounded or paid out twice a year, so we have N equals 2. What else do we know? We know that the time is 30 years. And then the question is, what is that account balance at the end of those 30 years? So what is that final amount? Okay, final amount with interest. So it's 10 grand plus interest. So that's it. Let's go ahead, plug in check. So we have A equals, the principal is 10,000. Next time, remind me to write down the facts, and then I'll write down the formula, because I don't know if I'll be able to, I don't think I can fit it here. I'm going to write out the formula again. So we have A equals P times 1 plus R over N raised to the NT power. Fantastic. So we want to know what the final amount is. The principal is $10,000. We have already identified all the ingredients that we need. We're just plugging and chugging. Okay. Times 1 plus R. The rate is 0.025. N, interest is compounded twice a year, raised to the NT power. So N is 2 and the time is 30. Fantastic. Well, that's pretty much the answer. But if you tell me that this is the final amount, I have no idea what that is. So let's go ahead and put that in decimal form. I want to point out that to solve for A, there's nothing that we need to do to both sides. It's strictly arithmetic. So you don't have to show me the in-between computation. You can go straight to answer. Okay, so let's just use our calculator. Solar. Oh, okay, cool. All right, so we have 10,000. 0, 1, 2, 3. Open parenthesis. 1 plus. And it's up to you how you want to write this. The fraction bar, I will always use the division symbol. So we have plus 0.025. Sorry, I got distracted. My phone woke up. Yeah, that's why. Like, be careful what you say in front of your phone. They're always listening. All right, cool. So we have 10,000 times 1 plus 0.025 divided by 2. Close that grouping symbol, and then raised to, where am I? Raised to the 2 times 30. You can enter 2 times 30, or you can just enter 60. Okay, bear in mind that if you enter 2 times 30, the worst thing you can do to yourself is write it correctly on paper but punch it in wrong. The way I put it in my calculator, the way it reads, it's taking this base, raising it to the second power, and then whatever that simplifies to, that will give us 30. Okay, so go ahead, put the open parenthesis. So 2 times 30, or just 60. Fantastic, and then that's it. For those of you that wanted to show me what this simplifies to, I mean, that's fine. We could do that. Let's see if we don't have too many decimals, okay? So we have 1 plus 0.025 divided by 2. You know, or for fake extra credit, we don't have like a boatload of decimals, so I'm going to go ahead and write this, okay? Hopefully that will minimize the likelihood of me punching it in wrong, okay? So we have that the sum simplifies to that. No rounding. Whenever we round, if we round, it's always to the very end, okay? And this is being raised. Why don't we evaluate product of 2 and 30? That will give us 60, and that is being multiplied by 10,000. Cool. So the one advantage of starting to evaluate your expression is you will reduce the number of keystrokes. Now, someone said, what if you had like a boatload of decimals, like you couldn't even fit? Then we would just go straight to answer. Okay, so let's punch it in. So we have 10,000, 1, 2, 3, times 1.0125. Parentheses are no longer needed because we just have a single number. We don't have like an expression right here. So times 1.0125 raised to the 60th power. Okay, I'm going to hit enter. Okay, so A represents the final amount, so it's the principal plus interest. So we're talking money. So if we're gonna have decimals, we need to have no more than 2. So with your permission, I'm gonna copy all these numbers, 2 decimals, and then 1 more to help me round. So we have that the final amount, it's about 2107, 1.81, and 1 more to help us round. Okay, so we are rounding to, again, we're talking about money. So if we have decimals, we can have no more than 2. So we're going to round to the second decimal, or the hundreds place. we're gonna go ahead, look right next door, and in this case, you know, if it's 5 or higher, we'll round up, and in this case we are rounding down. Less than 5, we're gonna round down, but keeping the decimal as is. So we have 17012, and I don't know how to read this until I have the commas. Okay, so that's pretty sloppy, so let me just write it over. So we have $21,071.81. Okay, so the question is, assume we have $10,000 to invest. We're gonna put it away for, I don't know what, something. How much are you gonna have at the end? Okay, what is that account balance? Okay, so at the end of 30 years, well, we started with 10 grand. After 30 years, we're gonna end up with 21,000. Okay guys, so that is my time, but please come back. Okay, we have 2 more sets of problems, but I'm gonna break them into separate videos. Thanks.